and has even had the chance to go to the field with them. He holds a bachelor's degree in anthropology and is super excited to talk to you all today about the museum's upcoming paleo projects, Dueling Dinosaurs. Thanks.
Hi, everybody. It's really nice to be here with y'all today. So we are going to be talking about something that we're really super excited about here at the museum. We have a wonderful, amazing paleontology lab, and with some world-class paleontologists here at the museum. And we are really excited to bring to North Carolina the Dueling Dinosaurs, which is a one-of-a-kind, once-in-a-lifetime pair of dinosaurs that were buried in such a way that we're going to learn so much fantastic things about them. And they have the two dinosaurs preserved in this specimen are the most famous dinosaurs. We have Tyrannosaurus and Triceratops. So we're going to talk a little about them today, what the new exhibits are going to be like, and what our scientists are hoping to learn from these dinosaurs. Now, if you guys have the option to spotlight us, that would be super awesome, because we have some really cool pictures, and we also have some fossil replicas from Triceratops and Tyrannosaurus that we're going to be sharing with y'all today. Alrighty, so I will go ahead and start my slides. Alrighty. So Tyrannosaurus and Triceratops, we have known about these dinosaurs for well over, found in the late 1800s here in the United States. They were part of a time in paleontology called the Bone Wars, when scientists were going out west, and they were in a race to see who could name the most dinosaurs, new dinosaurs. And so out of them, we got the three-horned face Triceratops and Tyrannosaurus rex, the tyrant lizard king. And for a really long time, this was kind of our mental image of these dinosaurs. Very upright, tail dragging, very reptilian. This painting is by Charles Knight in 1927, and it was commissioned by the American Museum up in New York City as part of their unveiling of the skeletons of these dinosaurs. Now, fast forward a few decades, and our ideas of dinosaurs have progressed far from what they were in the 1920s. In 2006, a pair of dinosaurs were found in Montana, the Dueling Dinosaurs, and they were found by Clayton Phipps. Now, Clayton is a cattle rancher in Montana, and in his free time, he likes to fossil prospect. He likes to look for dinosaurs on his property. And one day in 2006, he stumbled upon the hips, the hip bones of a Triceratops. And he didn't think they were a really big deal. Only part of them were coming out of the ground. And he was actually going to leave them behind and just put his energy elsewhere. But his cousin, who had never been fossil hunting with him before, was very excited. This was the first dinosaur fossil he had ever been part of finding. And so he convinced Clayton to go back and further dig up this Triceratops pelvis, this Triceratops hips. And it was a good thing that happened, because what ended up happening is that they found the Dueling Dinosaurs, the two most complete skeletons of these dinosaurs that anybody has ever found. The Tyrannosaurus is 100% complete. Every single bone in its body is preserved, including skin impressions, possibly even soft tissue. So that's never happened before. And the Triceratops, while it's missing a few things, the Triceratops is still almost entirely complete. Again, we do not have this is the most complete Triceratops as well, includes skin impressions and other things. So this was in 2006. Once the fossils were fully prepared out prepared out of the rock, they entered legal limbo. So the way fossils work in America is when our paleontologists here at the museum go out looking for fossils, they go onto federal land. They get the special permits through the Bureau of Land Management so that they're able to collect collect the fossils that they found. The dueling dinosaurs, however, were on private property. And with the United States and property laws, that put their ownership up for debate. So what happened on the land that they were found on, there was two families. One family owned the mineral rights, the other owned the surface rights. So the family that owned the surface rights, that's where they grazed their cattle. They basically owned the land itself. The family that owned the mineral rights, however, owned everything that was underneath the surface. So if oil or gemstones or anything like that was to be found on the property, that family would own it. And so once the dueling dinosaurs went up for auction and the reserve price climbed into the multi-millions, the two families entered into a legal dispute about who would get the fossils. Traditionally, fossils have been considered part of the surface rights, but an argument was made that since they are minerals, since their fossils are bones that have turned into rock, they could be considered minerals as well. And this started a lot of contention within the paleontology community, because since fossils had traditionally been part of the surface rights, if this was suddenly changed, and now the mineral rights, fossils belong to the mineral rights, millions of fossils all over the world in museums and universities and other institutions, suddenly their ownership would come up for question, and there would be a case for if fossils found previously on private land now having to be resold or repatriated or being lost from collections. So ultimately, in 2020, the court case was finally settled, and the Supreme Court of Montana decided that the fossils belonged to the surface rights, like they always had. And so the North Carolina Museum, which had been in the process of purchasing these specimens, was able to finalize all the paperwork, and we were able to bring the dueling dinosaurs here to North Carolina. Now, because we have these once-in-a-lifetime specimens, and they're going to show us so much about these two iconic dinosaurs, naturally, we have to build a whole new exhibit and a whole new lab. Our current paleontology lab is on the 3rd floor, and the blocks that these fossils are in weigh several tons. And so structurally, we can't really have them on the 3rd floor. Getting them into the lab would be a problem, and the lab just isn't big enough to handle them. And so we are going to be building the new Dyno Lab, which is a state-of-the-art paleontology lab where our paleontologists will be prepping out and studying these fossils. Our head paleontologist, Dr. Lindsay Zano, she had this idea of having the public really being able to interact with the paleontologists while they're working and with the fossils. And so what the new lab is going to be, it's kind of going to be an open air lab where there's not a wall, there's not a glass plane between the scientists and between our museum visitors. And so visitors to the museum will be able to talk to the paleontologists and see really what they're doing. And as Dr. Zano said, the entire experience of inviting the public to follow the scientific discoveries in real time and participate in the research will set a new standard for museums. This is going to be a very unique lab, and it's going to be the first of its kind. And Dr. Zano is hoping that, you know, it kind of sets a blueprint for engaging everybody in the scientific process. And the Dyno Lab, it is groundbreaking, is going to be hopefully in September of this year. It'll probably take about a year or so before it is open to the public. Opening date is still to be determined. But yeah, so that is what the museum is planning on doing with these two awesome specimens. On the public facing side, now we get to the research side, which I'm personally very excited for. So what's next? So of the two dinosaurs, we'll start with the Triceratops. Triceratops was about 25 to 30 feet long. It belonged to a group of dinosaurs called the Ceratopsians. So those dinosaurs with the neck frills and the big horns. There are two species of Triceratops. There is one called Triceratops horridus, and there's another called Triceratops porsus. The Dueling Dinosaur specimen is Triceratops horridus, which came a little bit before porsus. It kind of evolved into horridus evolved into the other one. And we're really, really excited with what we've been able to see exposed so far in this specimen. What we found is we have found what we believe are skin impressions along the frill, which have never been found before. We believe that there's also skin impressions further on the body, but that's going to take some time to figure out if that's actually there while prepping out the specimens over the next few years. Another really cool thing with these specimens is they were buried super quickly. We're still not sure exactly what buried them, whether it was a flood or a collapsing sand dune or something like that. But the way these animals were buried and how quickly they were buried, everything is articulated as it was in life. You could see on the picture of the foot there, all the spaces between the bones, that is the exact same spaces as they would have been in life. So this is going to give us a lot of information about the soft tissue and kind of how dinosaurs' joints work, even how dinosaurs' joints worked, which is really, really cool. Another thing that we're hoping for is preserved pigments. Scientists have been able to basically shoot special lasers at very well preserved fossils, and they've been able to pick up the melanosomes, those little cell pigments of cell that give structures their colors. And so there's a few dinosaurs that we can now say what colors they were. And we're hoping that by the end of this process, we'll be able to say that for Triceratops and Tyrannosaurus, or at least have a good idea of what they were. Now, Triceratops, it's one of our most commonly found dinosaurs. About 40 to 60% of the dinosaurs found in the Dakotas, Montana, and Wyoming from the late Cretaceous, that end period of the dinosaurs, are Triceratops. It was kind of the cows of the Cretaceous almost. They were everywhere. And because of that, we have a really, really good understanding of their growth. We have found Triceratops skeletons all the way from hatchlings with this, this reconstruction kind of, I always thought they kind of looked like a little goblins almost, all the way up to fully grown adult animals. Now, one of the specimens that I want to share with you is a replica pair of Triceratops horns. And so these are a pair of Triceratops brow horns. So going right over the eyes. And one of the really cool things with these horns is that they changed shape over the animal's life. If we can pull up that picture again, what we can see is we can see how the horns shape as they get older. They start out as these little nubs. They become very vertical and almost sweeping back before eventually reorienting and starting to curve forward. So we can look at horns like this and we can make an estimate of how old the animal was. This probably would have been a young adult, late teenaged Triceratops when it died. And so Triceratops growth patterns are something that we already know from the fossil record. The dueling dinosaur, we believe, the dueling dinosaur Triceratops, we believe is a fully grown adult. And so that is going to be able to help us also understand the end period of Triceratops life. So older animals and how their bones and their bodies changed once they reached a more advanced age. The Tyrannosaur is the one getting the most attention. This is the 100% complete Tyrannosaur skeleton. It's the only one. It's the only one that's ever been found that has everything. And this, the full Tyrannosaur is about 18 feet long, which raises a lot of questions. One of the things our scientists are hoping to find out is this a juvenile Tyrannosaur? Is this kind of a teenaged Tyrannosaurus rex, not fully grown, or is it an adult? Is it an adult of a different species? Those are some of the most pressing questions, and we're hoping to be able to answer them. Either way, it's going to tell us so much about Tyrannosaurus's growth and how they aged. While we know we have a really good amount of information and detail with that about Triceratops, we really don't know how Tyrannosaurus grew up. And so this is going to be a really important specimen to help understand what Tyrannosaurus growing up would have looked like. Another really cool thing is we do have skin impressions of the Tyrannosaurus. We have it down there in the corner. We have from the arms and legs showing scale patterns very similar to the legs of modern day ratatites. So big birds like ostriches, emus, cassowaries, things like that. And then again, because of the way that it's buried, same thing with the Triceratops. We're able to see the amount of space between the bones, joints, all those things. So we're going to be able to do a lot of biomechanical studies to see just how this animal moved and how its body functioned. And another thing, other than the growth, figuring out if it's a immature Tyrannosaurus or something else, is also the impressions over its body. So while on its feet, while we have the scale ones, we haven't been able to really look more so over the rest of the animal. So hopefully things, as we prep out, we'll find things. And this could also answer a question about what Tyrannosaurus and its relatives were covered with. Now, most of the impressions that we have from other specimens so far suggest that Tyrannosaurus was scaly. We have scale impressions, like in this picture, showing scales from several parts of the animal's body. However, we don't have anywhere close to the majority of the animal preserved. We mostly just have things from the neck, the base of the tail, and the legs. Now, a lot of Tyrannosaurus's earlier relatives, however, particularly those from China, are covered in feathers. Now, China, in Liaoning province, there's a lot of beautifully preserved fossils that show all this detail. They show the skin, they show the feathers, they show the entire outline of the animal. And the reason was because in Liaoning, during the Cretaceous, there was a volcano that covered this forest in a layer of ash. And the very fine ash was an awesome way of was awesome at preserving all these details. So Dailong, an early relative of Tyrannosaurus, we know is covered in feathers. So the genetic capability for feathers was there with Tyrannosaurus. Hopefully the Dueling Dinosaur specimen will be able to help us see if they actually did have feathers, because just because you have the genes for it doesn't mean it's gonna happen. And so, yeah, so that's another question that hopefully we'll get an answer to. And so, yeah, so these are the immediate questions our paleontologists want to know. How did Tyrannosaurus grow? How old were these specimens at death? Was it a juvenile? Was it a different species? Right now we're saying juvenile, but we haven't really looked at the specimens. It's going to be a few years from now when they're out of the rocks. What did Triceratops and Tyrannosaurus look like? Feathers, scales, possible pigments. Be really cool if we could figure out what color Tyrannosaurus rex was. And then finally, behavior. How did these animals die? Was it a scavenging? Was the Triceratops already dead? The Tyrannosaur came along, thought it was an easy meal, and then they were both buried. Were they actually dueling? We're calling them the dueling dinosaurs, but we don't know for sure. So they could have been fighting. They could have gone into a fight and then been rapidly buried that way. There's some fracturing on both specimens that is going to be really important for figure out if those fractures occurred prior, like while the animals were in the process of dying, or afterwards after being buried, just kind of like that. Or finally, was it coincidence? Did these two animals never meet at all during the entire course of their lives, but they just happened to both be carried to the same burial place because of something like a flood? A lot of mass graves of dinosaurs are often believed to be because of floods putting a lot of bodies together at once. And then this is the team that will be figuring out these questions. Our head paleontologist is Dr. Lindsay Zano. Now, Dr. Zano has traveled all over the world studying dinosaurs. Her big interest is the Tyrannosaur. Dr. Zano, she focuses on those meat-eating predatory dinosaurs. We call them theropods. And she's named several. She's named several new ones, including one called Maros, which is the earliest Tyrannosaurus relative found here in North America. It was found in Utah. She named it about 2 years ago. And so she's really, her big questions is she wants to know about Tyrannosaurus's growth. She wants to know feathers versus scales. So she's going to be focusing on the T-Rex skeleton. And then we also have Eric Lund. Eric Lund is a ceratopsian expert. He focuses on those big horned dinosaurs. He's named several of those as well. And he really wants to know, he's interested in the Triceratops's growth, integument, possibly color, what color the dinosaur was. And so he'll be leading the research into the horned dinosaur, the Triceratops. And so together they will be bringing these dinosaurs to North Carolina and hopefully bringing the museum's visitors with them as they're answering all these questions in real time. And then the last part that we're super excited for is to understand the environment that these animals are from. What was Montana like 65 million years ago? So Jim asked a question in the chat about how, if we know what event took place to preserve so many fossils in Montana. That's a really, really good question. So during the last part of the age of dinosaurs, the very end of the Cretaceous, so about 67 to 65 million years ago, Montana looked very different than it does today. Today, it's the Badlands. It's kind of very dry, scrubland, that kind of thing. But during the Cretaceous, it was beachfront property. There was an ocean. There was a shallow ocean in the middle of the United States and Canada. And so Montana would have been a very lush, lowland, swampy environment, kind of like this picture. And these environments are really, really good for preserving dinosaurs. For a fossil to form, basically an animal needs to die, but it needs to die somewhere near water or somewhere where it's going to get buried very, very quickly. So things like scavengers can't pull things away, natural processes can't break apart the body, break apart the bones, all those things. And so the environment that Montana was back then was very conducive to creating fossils. Not everywhere, not every environment is good at doing that. Dinosaurs that lived in the mountains, rainforests, grasslands, things like that, those dinosaurs, they were just in environments where fossils didn't really form. So we're probably never going to know that they even existed unless, you know, something fortunate like the volcano that went over the rainforest in Liaoning, China, that covered them that way. So generally the reason Montana has so many fossils is just that the environment that it was very good at creating fossils. And so one of the things with the dueling dinosaurs is we want to know what their environment was like. We know that it was like kind of this coastal, swampy plains, lowland environment, very similar to the North Carolina coast today, actually. And to find out more about this environment, we're starting a program called Citizen Scientists. Now, this is geared towards middle school science classrooms. And what we'll be doing is we'll be getting sediment from a place in Montana called Natalie's Channel. It's on the same property that the dueling dinosaurs were found, just about half a mile or so away. And Natalie's Channel is a microfossil site. And so what we'll be having students doing is they'll get these giant bags of sediment and they'll be sifting through and they'll be looking for small fossils that show us about the other animals that were living with the dueling dinosaurs. So everything from gar scales, mammal teeth, crocodile osteoderms, so those scaly scutes and their teeth, turtle shells, snake bones, even the teeth of other dinosaurs. And so this is going to be getting North Carolina students involved in the research to figure out what exactly the Hell Creek looked like 66 million years ago, and what other animals were living in the shadows and making up that ecosystem. Because, you know, When we think of the age of dinosaurs, we think of those big dinosaurs, but there was a lot of other things living in their shadows, making everything run. Circle of life and all that. And yeah, and so from the picture at the beginning, Charles Knight in 1927, obviously our understanding of dinosaurs has changed drastically in the past 100 years. It's probably in the next 100 years, it's probably going to change even more. One of the exciting things about paleontology is that we are always learning new things. And everything that I told you today, theoretically, tomorrow, find a new specimen and it could be wrong. Paleontology is always changing. So this is art that was commissioned by the museum for the Dueling Dinosaurs exhibits, using the current science for what these dinosaurs looked like. But who knows, once that lab is completed and the research begins, this picture could be just as out of date as the one from 1927. So that is our presentation now about the dueling dinosaurs and what's going on in paleontology at the museum. So if y'all have any questions, we would be happy to answer them.
Well, hi, this is Rod. I just want to say thank you for sharing this this amazing exhibition and news with us. It's really exciting to see what all is happening at the Museum of Natural Science. And I do want to encourage anyone who may have questions to post those in the chat. And if anybody in the room has, please post that in the chat so that we can get those answered. Meanwhile, I do have 3 questions for you. First of all, you mentioned the new SECU Dyno Lab. And could you just describe the location? Is that going to be, there on the footprint of the museum or another location? That's one. Another question is, so you may have mentioned it, forgive me if I missed it, but the acquisition cost of this fossil, I'm wondering about, what did it take for the museum to acquire these fossils, and where did that funding come from? My third question, and maybe the most important, is along with these fossils, did you discover any DNA, and will we be able to replicate dinosaurs going forward?
All righty. Yeah, so the SECU Dyno Lab, so at our museum, we have the 2 buildings. We have the Nature Education Center, which is that older part of the museum. And then we have the Nature Research Center, which was created and built in 2012 and houses most of our labs with the glass fronts that you can look in and see the scientists working. The Dyno Lab is going to be on the 1st floor of the NRC. So right here in downtown Raleigh, we're re-renovating the 1st floor, taking out some exhibits to make some older exhibits to make room for the new lab, and just a small exhibit about Hell Creek and what we know about it right now. The acquisition cost, that's a very good question. I know that the first time back in, I believe, 2009, that the specimens went up for auction. I believe it was around 5 to 6 million for the pair, and that was not met. So they went back into storage, and then a few years later, Dr. Zano approached about getting them for the museum. I know that it is a few million. I do not know the actual they have not shared that with us in education. But yeah, no, it's a few million. Yeah. And then DNA and replications. So, oh yeah, and then we were able to purchase the specimens through donations from a lot of sources. SECU, as always, has been a wonderful sponsor of the museum and the museum's mission of bringing the natural world of North Carolina to everybody. And then also Duke Energy and GlaxoSmithKline have been huge donors. So we're very thankful for them and that we were able to, they helped us get these specimens. And then, yeah, as far as the DNA and replications, so we, kind of a complex question. So we do have some soft tissue stuff that has been preserved and we have been able to look at. We have a scientist at NC State, Mary Schweitzer, and she looks at proteins, and she has found blood proteins preserved in a Tyrannosaurus thigh bone, in a femur. And what she was able to look from that is that Tyrannosaurus' closest living relative is a chicken, which is pretty cool. Actually, we can look at a fossil, or we can look at a fossil replica we have. So this is a modern day chicken, like you might eat at Bojangles. And there's a bone up there at the front called the furcula. Its more common name is the wishbone. And the furcula is a bone that is unique to birds. No other animal has a bone quite like this furcula right here. That is, except for meat-eating theropod dinosaurs. This is the furcula of a Tyrannosaurus rex, a fully grown Tyrannosaurus rex, but T-Rex had a wishbone too, just like a modern day chicken. And the soft tissue protein evidence that Dr. Schweitzer found supports that. As far as DNA though, DNA with a nucleus and DNA that we're able to use to clone things, that probably won't happen. DNA breaks down relatively quickly during the fossilization process. And so while we have been able to recover DNA from more recently extinct animals, particularly Ice Age animals that have been found in the permafrost up in Russia, dinosaurs, we're probably not going to be getting their DNA. We'll be lucky if we get those melanosomes pigments. But yeah, plus there's also an entire series of movies that tells us why that might be a bad idea. So.
Well, again, thank you. And with that, I appreciate your addressing those questions. If we have any others, please post them in the chat. Otherwise, President Bob, I'll turn it back over to you.
The Cary Rotary, and dueling dinosaurs for me, I learned a whole lot today. I had to take some notes, so much so 100% of a T-Rex, 100% of a Triceratops. I'm excited. I can't wait for September because I want to get a chance to go and check that out. I know my kids will. I know my wife will as a school teacher. But you did say a few things that I think Dr. Lindsay Zano should reach out and try to get some answers. There's a doctor that I've worked with very closely. His name is Dr. Steven Spielberg. He'll be able to help with some of those unanswered things that you were questioning before. But our resident member, Jerry Miller, has some cards that he's made up for you. We're going to send these over to you guys. Thank you so much for presenting today, and thank you for educating each and every one of us.
Thank you for having us. We had a lot of fun.
Thank you, Darren, and thank you, Luka. It's great to have one of Cary's own come and present. It's great to have you connected to such an exciting project. I want to share, it's been a couple of weeks since we've been together, so I need to share some updates and anniversaries and birthdays. If you run into Mark Lawson or John Ogle or Joe Sturdivant, wish them a happy birthday. They've all celebrated birthdays in the last 2 weeks. Ages and exact dates not to be disclosed. We want to recognize Tom Brooks and Howard Johnson, who on the 1st of July celebrated their 35th year of membership. And tomorrow, aside from being Bastille Day, will be Jim Lovejoy's 12th anniversary with the club. So congratulations, Jim. Reggie, if this is news to you, it's already too late. So happy wedding anniversary to you and Lisa, 26 years. Frank, you've got the 2-day warning. Where did I see Frank? 2 days to go for you and Terry, 15 years, congratulations. And if you see Ernie and Joyce Faulkner, they'll be celebrating their 43rd year of marriage. So we continue to move forward. Way to go, club. All right, next week, our program sponsored by Don Finkbeiner is Don Stevenson will give us a talk on the petroleum industry and update all of the always interesting ups and downs in that business. Meal to be determined. It will not be a cheeseburger. In 2 weeks, Sal Camerata will bring us Mark Dill with a presentation on the legend of the first super speedway. So all you NASCAR fans will be sure to be in attendance, no doubt. All right, well, I want to thank Pat for arranging our speaker, Luka for a fantastic program. And ask Kristen Sutton if she'd lead us out in the four-way test.
The things we think interviewed.
Is it the truth? Is it fair to all concerned? Will it build goodwill and better friendship? Will it be beneficial to all concerned?
Hi, everyone.
Rod,
Bye, Bill. Good to see you.
take care.